Dear First Secondary, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 4 Lesson 1. This is the first lesson in this unit and this is the last lesson in our geometry. Okay, the lesson is called Parallel Lines and Proportional Parts. This lesson depends on similarity and similarity rules and looks like the previous lessons of similarity. Let's start the lesson. Okay, now we are going to use the similarity of two triangles to conclude the rules of this lesson. Okay, first, if we have triangle ABC like this and we draw straight line XY in which XY parallel to BC, then we get two similar triangles AYX and ABC as we explained before. Let, for example, AY equal 8 centimeters and AX equal 6 centimeters, and also let AB equal 12 centimeters and AC equals 9 centimeters. So there is a proportion between AY and AB, AX and AC like this. AX over AC equal AY over AB. This is as what we studied in the similarity. AX over AC 8 over 12 and AY over AB equals 6 over 9. The two ratios gives me 2 over 3, and this is a proportion between AY and AB, AX and AC. This is as we studied in the triangle similarity. Okay, now let by using the same example here to find YB, it will be 12 minus 8 equals 4, and to find XC, it's equal 9 minus 6 equal 3. Okay, now by making a proportion between AX and XC, okay, AY and YC, here by looking 6 divided by 3 equal 2 and 8 divided by 4 equal also 2. So there is another proportion AX over XC equal AY over YB like this. AX over XC equal AY over YB equals 6 over 3 equal 8 over 2 over 4 equals 2. So this is a new relation depend on the same two similar triangles. Okay, now by looking to XC over AC, XC equal 3, AC equals 9, 3 over 9 equal 1 over 3. And also the same part in the other side, YB 4 and AB 12, 4 over 12 also equal 1 over 3. So YB over AC over AB equal XC over AC like this. It's equal 3 over 9, which is equal 4 over 12 equals 1 over 3. So we can, if we have straight line intersect the triangle like this, then this is divide the sides of triangle into proportional segments. This is what the theorem said. The theorem said that if a line drawn parallel to one side of a triangle, as we said here, and intersect the other two sides, intersect at X and Y, then it divides them into segments whose lengths are proportional. Okay, by looking to the triangle in general, AX over AC equal its corresponding in the other part AY over AB, and AX over XB over XC equals AY over YB, and also XB over AB equals YB over AB. And if you need to say XC over AX, it's also equal YB over AY. I don't write this this ratio. Okay, now let's study the next corollary. Corollary is a rule, okay, from the or result from the theorem. If a line is drawn parallel to one side of a triangle and intersects the other two sides, then it divides them into segments whose lengths are proportional. It looks like the theorem, but the intersection may be internally or externally, like this. This is a triangle and this is a straight line intersect the two sides AB and AC internally, like this, and parallel to BC. We get here AY over YB equal AX over XC and so on. Or the intersection may be externally, like this. If we have triangle ABC and the triangle comes from outside, so if I extend AB and extend AC like this, we get, okay, proportional segments. How come? XA over AC equal YA over AB, and also XA over XC equal YA over YB, and also AC over XC equal AB over YB, like this. AX over AC equal AY over AB, AX over XC equal AY over YB, XC over AC equal YB over AB again, AX over AC equal AY over AB. This is the first proportion. AX over AC equal AY over AB, and so on the next proportions. Okay, let's solve example 1. Here in this example, in each of the following figures, DA parallel to BC, then complete. Okay, now I need to find the length of AB. First, I'm going to call this one X. So, AE over EC equal AD over DB. So, 6 over 4 equals 3 over X. X here equals 3 times 4 over 12. 3 times 4 over 6. So, X equal 2. X equal 2. So, AB equals 3 plus 2 equals 5. You can find it by AD over AB equal AE over AC, but it's better to use this ratio, 6 over 4 equals 3 over 2 over X. Number 2, here we have AC equals 15, EC equals 6, AB equal 10. Okay, he asked me about BD, so I'm going to call BD X. Okay, now I can use AE over AC equal AD over AB, but it's difficult to use. But it's better to use 6 over 15 equal X over 10. So 6 over 15 equals X over 10. So X equal 6 times 10 over 15, X equal 4. Here X equal 4, so BD equals 4. Now in this case, those two parallel lines, I'm going to call AEX. So 2 over 6 equal X over 7.5. Again, 2 over 6 equal X over 7.5. So X equal 2 times 7.5 over 6. So X equal 2 times 7.5, 15. 15 over 6 equal 2.5. X equal 2.5. So AE equals 2.5. The next question. Okay. Here exactly the same. he asked me about the length of x. Okay, so it's better to use 3 over 5 equals 6 over x minus 2. Again, 6 over x minus 2 equals 3 over 5. Okay, x minus 2 equal 6 times 5 over 3. 30 over 3 equals 10. So send minus 2 plus, so x equal 10 plus 2 equals 12. X here equals 12. The other, here x power of 2. Okay, here 5 DE parallel to BC, so 5 over x power of 2 equal 4 over 5. Again, 5 over x power of 2 equal 4 over 5, like this. So x power of 2 equals 5 times 5 over 4 equals 25 over 4. By taking the square root, so x square root 25 over 4, which is 5 over 2 over or 2.5. So x, I don't write negative or positive because x here is a length of a side, but here x is power of 2, so I can, so it is negative or positive because this is x power of 2, so x here has two possible values. Okay, here DE parallel to BC, so x plus 4 over 3 equal 15 over x. By making cross multiplication, so x times x plus 4 equal 15 times 3. X times x equal x power of 2 plus x times 4 equals 4x equal 15 times 3 equals 45. I'm going to send the 45 to the left side, so x power of 2 plus 4x minus 45 equal to 0. By using the calculator or factorization or formula, it's up to you. So x equal negative 9 or x equal 5. Now this one is refused because x is a length and the length is not negative, so the value of x equal 5. Now let's study example 3. In this example, in the opposite figure, AD parallel to DE, AC equals 6, BC equal 4, CD equal 3. As we see, find the length of AE. Okay, now I'm going to call this one X. Since AB parallel to ED, therefore, I'm going to write the proportion EC over CA equals DC over CB. So x over 6 equals 3 over 4. So x equal 3 times 6 over 4 equals 4.5. This is x. Therefore, EC equals 4.5, but he asked about AE, therefore AE equals 6 plus 4.5 equals 10.5. Now let's study the converse of the theorem, and we use the converse to prove that the two lines are parallel. Okay, if a straight line intersects two sides of triangle and divides them into segments whose lengths are proportional, then it is parallel to the third side. Okay, first, if we have a triangle like this and we draw xy like this, if AY over YB equal AX over XC, then XY parallel to BC, or AY over AB equal AX over AC, so XY parallel to BC, or if YB over AB equal XC over AC, so they are parallel. You can use any of the previous proportional. Okay, another case, if the line comes outside the triangle like this, if XA over AC equal YA over AB, or XA over XC equal YA over YB, or AC over CX equal AB over BY, so the two lines are parallel. Okay, this is the ratios that I explained. AX over AC equal AY over AB, as I said, AX AC AY AB, and so on. So in that case we get that XY parallel to BC, and like this here also XY parallel to BC, and this is the conclusion of this converse. Okay, now in the opposite figure, AE equal 5, BE 4, CE 12, DE 15, prove that AB parallel to CD. To prove that BA parallel to CD, so I need to prove that any the ratio between two parts of the sides are equal. So here 5 over 15 equals 1 over 3, and 4 over 12 equal 1 over 3, therefore they are parallel. So since AE over ED equals 5 over 15 equals 1 over 3, exactly as much as you prove that they are similar, and BE over EC equals 4 over 12 equals 1 over 3, therefore AB is parallel to DC. It's a very easy question. Now example 5. In this example, here we have in the opposite figure XY parallel to BC parallel to ED, and AB equal 6, AC 5, AD 12, EY equals 4. Find the length of AE and DX. Okay, now to find AE, I will start with A. Okay, since BC parallel to ED, by looking here, BC and ED, so AC over AE equal AB over AD, again AC over AE equal BA over AD. It's easier to find AE direct, therefore AC over AE equals AB over AD, therefore 5 over AE equals 6 over 12, therefore AE equals 5 times 12 over 6 equals 10 centimeters, and now this is 10 centimeters. 10 minus 4 equals 6. Okay, now I can find dx. I can find dx. Okay, it's better to use a ratio between dx over dA equal EY over EA. Again, dx over dA equal EY over EA. Since XY parallel to ED, therefore dx over AD equals EY over EA or AE. Therefore dx over 12 equals 4 over 10. Therefore dx equal 4 times 12 over 10 equals 4.8. This is dx. Dx equal 4.8. Next, in the next question, okay, here we have DF parallel to BC and AD equal 6, BD 5, AE 3.6, FC equal 5.5. Prove that DE parallel to BF. Okay, first I need to find the length of EF. Okay, by using the triangle ABC, FD parallel to BC, so AD over DB equals AF over FC. Okay, since FD parallel to BC, therefore AF over FC equals AD over DB. Therefore AF over 5.5 equals 6 over 5. Therefore AF equals 6 times 5.5 over 5 equals 6.6. So AF equal 6.6. So FE equals 6.6 minus 3.6 equals 3. Therefore FE equals 3 centimeters. Okay, now I have here to prove that ED parallel to FB. I have the ratio. I have to find the ratio AD and DB, AE and EF in triangle ABF. AE over EF equal 3.6 over 5 over 3 equal 6 over 5, and AD over DB equal also 6 over 5. Therefore, from the previous 6 over 5, 6 over 5, therefore ED parallel to FB. Okay, next question. ABC triangle and D belong to AB. Now I'm going to draw triangle ABC like this. I'm going to call A, B, C. Now D belong to AB where AD equal to 3AD equal to BD. This is a proportion. AD equal 2 and DB equal 3. Okay, so, or AD equal 2x, DB equal 3x. So I'm going to put D here in this position. D, okay, in which AD equal 2 and DB equal 3. 1, 2, 3. Okay, now E belongs to AC. E somewhere here in AC, in which 5 CE equal 3 AC. CE equals 3x and AC equals 5. Okay, CE equals 3. From C to E 3, and from AC equal 5. AC 5. If CE 3 and AC 5, so A equal 2. So E here in this position, in which CE 3 like this and AC 5, so AE equals 2. Okay, now if I connect between AD, it will be parallel to BC. It's very clear. Okay, now AX drawn to intersect BC at X. So I'm going to draw AX like this, intersect BC at X. Okay, now AF equal 8. There is F somewhere. And AX equal 20. AX equal 20, okay, it's clear. It's 20 centimeters. F belong to AX such that AF equal 20. Okay, now I'm prove that D, F, and I don't write F because I don't know its place. Okay, prove that D, F, and E are collinear. So I'm going to connect E and F, E and D like this. So F lie here in this position. This one equals 8 centimeters. And AX equal 20, so FX equal 20 minus 8 equals 12 centimeters. Let's start the proof. He asked me for what? He needs to prove that E, F, and D are in the same straight line. Okay, now since 3AD equals 2BD, therefore AD over BD equals 2 over 3. This is number 1. And since 5CE equal 3AC, therefore AE over EC equals 2 over 3, and this is number 2. Since F belongs to AX, therefore FX equals 20 minus 8 equals 12 centimeters. Therefore AF over FX equals 8 centimeters over 12 centimeters equals 2 over 3, and this is number 3. 1 equal 2 over 3, 2 equal 2 over 3, 3 equal 2 over 3. From 1, 2, and 3, therefore E, F, D are collinear. The next question. ABCD parallelogram So I'm going to draw a parallelogram like this, and I'm going to call it A, B, C, D, A, B, C, D. Okay. E belong to ray BA. So I'm going to draw ray BA like this, and I'm going to put E here somewhere. Okay. Now E doesn't belong to AB, as I said. Draw EC, connect AC like this. Okay, to intersect AD at F, this is F, and intersect BD. So I need to draw BD like this, and at M. This is the intersection between BD and EC. Okay, prove that CM to the power of 2, CM power of 2, equal MF times ME. Now I have many similar triangles. Okay, so I'm going to look to the required to choose the best triangles I'm going to choose. Okay, CM, MF, and ME. CM here, and MF here, and ME, okay, in this triangle. Now, by looking to the two triangles DMC and DMC and the triangle EBC. Here angle D and the angle B are equal. Okay, angle E and the angle C are equal, so triangle MBE similar to triangle MCD. Okay, since ABCD is a parallelogram, therefore AB parallel to CD as we see. Therefore CM over ME equal DM over MB. I choose this one because we have CM here and the ME here. This is number 1. Okay, by looking also to triangle DMF and MBC. Here this angle equal to this angle, alternate, and also angle F equal to angle C, alternate, because those two lines are parallel. Okay, the second part from the question, therefore DA is parallel to BC, therefore FM over MC equals what? FM over MC equals what? Equal DM over MB. And this is number 2. By looking carefully to 1 and 2, we find here this ratio DM over MB, and also the same ratio here. Okay, from 1 and 2, therefore DM over MB, DM over MB, therefore CM over ME equal FM over MC, like this. CM over ME equals FM over CMC. Therefore, by making cross multiplication, CM times CM equals CM power of 2 equal FM times ME times ME. This dot means times, so CM power of 2 equal FM times ME. This is the required, and this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next lesson. Assalamu alaikum wa rahmatullah wa barakatuh. Mr. Ahmed Mahmoud was with you.